So a sketch would be a good idea. So we have a bridge in a semi-elliptical arch. So we have half of the ellipse, and it has a span of 52 meters. The height of the arch at a distance 24 meters from the center is to be 5 meters. What's the height of the arch at the center? All right, so we can figure that out. So 52 meters across. So let's draw ground level here. And then if the total span is 52, half of that would be 26, which would be the semi-major axis. So let's go 26. How about 10? Let's go 5, 10. Oops. So that can be 0, 15, 20, 25, 30. And we are at 26. It's just going to be about here. So then the other way, 5, 10, 15, 20, 25, 30. So about here-ish is the other part. And let's see, we don't know the height yet, so how far up we are on the minor axis, but we do know the height of the arch at a distance of 24 meters from the center. So there's 26, here's 24 is about right here, is going to be 5 meters. So let's say this is my 5 here, and then 10. So we go through the point 24, 5 right there. So our ellipse heads up, goes through there, and there's a matching point on this side. That would be the 24, 5 on this side. Oops, that's not 0 over there. That's better. And then somewhere up here, I'm just going to make a wild guess. It's the top of the ellipse. And that's a big question mark. Where is that height right there? So let's see. Let's work out what we do know. So general form for an ellipse, x minus h squared over a squared, y minus k squared over b squared has to be 1. And I just designed this to be centered at the origin here, so my h and k are 0. So we're centering at 0. So now I have x squared and y squared. Now we don't know b here, so we're just going to label that b squared, but we do know that a is 26. Now we don't know b, but we do know that we have that point right there, 24, 5, and so we can just plug that in and solve for b. So we have 24 squared over 26 squared plus y is 5, excuse me. 5 squared over b squared has to be 1. We just need to solve for b. So we can subtract the 24 over 26 squared to the other side. So 5 squared over b squared is equal to 24 squared over 26 squared. Oops, 1 minus that. Sneak in the 1 minus there. And it would be nice to clean up that 1 minus, so we could look at that as 26 squared over 26 squared minus the 24 squared over 26 squared. So then the other side can be looked at as 26 squared minus 24 squared over 26 squared. And if we flip both sides, we'll get the b in the top. So let's go to a new page. So I'm going to write it as b squared over 5 squared equals 26 squared over 26 squared minus 24 squared. So we can multiply the 5 up and then take the square root. So 26 squared times 5 squared over 26 squared minus 24 squared. And if we want b, we just take the square root of all of that. And all of those squares do not cancel. Order of operations stands in the way of our denominator because of the subtraction there. So I can clean up the numerator a bit, but not the denominator. Since that's a multiply, that works well with square roots. So that's going to be 26 times 5 over that square root of the difference, which doesn't clean up. And then we just need a calculator and see if that number seems reasonable in my sketch. And again, I just made a wild guess as to where the top is. Maybe it's around 15, maybe it's a little higher. Thinking it might be a little higher. Let's go take a look, and then we'll see if we got it right. Let's clear out that old ellipse. So first thing is we're going to calculate our b, and we believe b is equal to fraction with 26 times 25 in the top. Or no, 26 times 5, excuse me. And in the bottom, we get the square root of 26 squared minus 24 squared. All right, well, that's a nice number. 13 is what we think b is. So in my picture, that seems kind of reasonable. I didn't do too bad guessing at that sketch. So claim here is that this, with a few more steps, simplifies to b equals 13. That's 10. 15 would be up here. Yeah, that's, I guessed right, about 13 right there. So we think b equals 13. Next thing we have to check is, did we really get the point 24.5? Check that on my calculator. So next thing I'm going to do is graph what I think my ellipse is. So I think it's x squared divided by 26 squared plus y squared divided by 13 squared equals 1. And, oh, it's just bigger than my screen, so we need to zoom out. There she is. All right. And then I think I should have the point 24.5. So to check that, I'm just going to plot the point 24.5 and see if it sits on the ellipse. And bang, there it is right there on the ellipse, the point 24.5. And again, now it looks like it's on the ellipse, but the only way to really check is to actually plug in 24 for x and 5 for y and see if we get 1, which we can easily do. So 24 squared over 26 squared. If we add that to y equals 5 squared over 13 squared, we should get exactly 1, which we do. Nailed it. Definitely worth drawing a picture to kind of double check too. Computer draws a great picture.